Example 5, find each limit. Okay, let's look at A. Limit of sine x as x approaches infinity. So first of all, let's think about the range for this function. Okay, so the range of sine x is going to be between -1 and 1. Okay, so we can use the squeeze theorem here. Okay, we're going to do this. If the limit of -1 as x approaches infinity is equal to -1, and the limit of 1 as x approaches infinity is equal to 1, then the limit of sine of x as x approaches infinity would have to be between -1 and 1, which means the limit does not exist. Okay, if you think about this, if we would graph the sine function would go like this, right? It would be a wave here, and it would just keep going up and down, up and down. As it goes towards positive infinity, it's just going to keep bouncing between -1 and 1. That's why this limit does not exist. Let's try B. We're going to start this off the same way. We're going to start with sine of x, and we're going to look at the range. We know that the range for sine of x is going to be between -1 and 1. And then let's do this. Let's divide each of these functions by x. Now that should still be true. Okay, now let's use the squeeze theorem. So, if the limit of -1 over x as x goes to infinity, that would equal 0, and the limit of 1 over x as x goes to infinity equals 0. Okay, since these two functions are both going to 0, and the sine x over x is being squeezed in between them, and both of those functions equal 0, then by the squeeze theorem, the limit of sine x over x as x goes to infinity must be equal to 0. Notice that that is different than the limit sine x over x as x goes to 0. This would be equal to 1. Make sure you keep that straight.